First, let's start with the concept of call by value. This is slightly different from some other languages. For example, Python is somewhat of a hybrid, using both call by value and call by reference in different scenarios. Call by value means that whatever values you give in a function in C are temporary variables rather than the originals. Call by value means that if we have an integer, num equals 5, and a function that takes in an integer, and we do something to that parameter inside the function, this will be a copy of the input, and will only alter it within here, not outside. It can be seen as a benefit as it leads to more compact programs with fewer extraneous variables. Alright, so to demonstrate call by value, let's get into VS Code. And we're going to write a function called power, which takes a base and an integer n and raises the base to the nth power. We'll do this by defining an integer p and saying n times we will iterate, and within the for loop we will say p is equal to p times base and return p. To make sure we don't forget our function prototype up here. And then just to make sure everything's working, we will define power num as, say, power 23, expected 8, and below we will run value power num. Let's compile this, and we see this function is working. So what we're going to do is define an int num equals 5, and then instead of having an integer here for the n value, we're going to say num. So we're going to want 2 to the 5th, which should be 32. And we're going to add an extra print statement in here that says original num, and we'll change this to new num. We'll keep the value the same to make sure everything's still working properly. Add in an extra new line here. Okay, so what we want to demonstrate is that despite the fact that n is being decremented inside this for loop, the num that we pass to this function, due to the nature of C, is simply a copy of this num. So even though it's being changed inside the function, it should stay the same in the main call. So let's compile this, run it, and as you can see, our function still works properly. We got 32, but the values of num stay the same outside the scope of this function, and that is call by value. Now let's talk about the final section of Chapter 1, external variables and scope. Variables within functions, including main, are local to that function. They come into existence when the function is called and then disappear when the function is exited. These types of variables are known as automatic. Automatic variables do not retain values from one call to the next, so they must be explicitly set each time. There is an alternative to automatic variables, and that is external variables. These variables are variables that can be accessed by name by any function. So how do we use external variables? Well, they must be defined exactly once outside of any function, and they must be declared in each function that wishes to use it. Before we jump into an example, let's make sure we understand what exactly define and declare are specifically referring to. Define refers to the place where the variable is created or assigned storage. For example, int num equals 10. That's a definition. A declaration refers to places where the nature of the variable is stated but no storage is allocated. As we'll see here, we use the extern keyword to signify an external variable, and then we can say int num, semicolon. That's a declaration. So now let's get into VS Code and see how we can use this extern keyword. We'll do our standard library, and then we'll say our declaration is extern int global var. Then we'll define it below and say global var is equal to 10. Next, we'll define a modifying function. It's modifying because it doesn't return any type. And we'll say global var is equal to global var plus 5. As a sidebar, another way to do this is to say global var plus equals 5. Now let's create our main function. And inside we'll say initial global variable and print that. Then we will run our modifier function to add 5 to the global variable. And then we will print once more the final global variable to see how it changed. And return 0. Now, let's run this. As you can see, it's initially 10, and then we modify it and add 5, and now it's 15. So that works. Now, an interesting aspect of extern is that C can implicitly recognize the visibility of global variables. So you'll see, if we just get rid of this declaration, it will look at this as a global variable because it's defined before everything. And if we compile this and run it again, we get the same output, no problem. But let's see what happens when we take this and we move it down underneath the modifier. We get an error, use of undeclared identifier global var, because it's down here and this function is trying to call it, but it hasn't internalized this yet. So how do we fix this? Well, extern can come in handy. We go back up here and say extern int global var, just like we did before. And now we compile this and run it, and it works no problem. This is also applicable to dealing with multiple files, which we'll get into over time, but for now, this is a simplistic approach to extern. That's going to do it for Chapter 1 of the C programming language. We learned all about the fundamentals of programming in C, like loops, functions, variables, and much more. I feel like it was a great review of core concepts and an intro to what C has to offer. If you want to stick around, please consider liking and subscribing and sticking around for the journey.